Ladies and gentlemen, it's a pleasure. I'm sorry I'm wearing a jacket. Having said that, I was asked by Deepak that I must talk about what is the next generation enterprises looking at. Since my company works at the intersection of art, science, and engineering, I said, let the picture say the 1,000 words rather than just me talking. So I'm going to just start this conversation with a 2-minute video that's really insightful, and hopefully it gives you a little more energy and hopefully settles you down.
I am a visionary, exploring a universe of data to sharpen our view of the most distant galaxies, and studying black holes to help prove Einstein's theory of gravitational waves. I am a healer, giving doctors the power to turn mountains of data into life-saving breakthroughs, identifying diseases like leukemia from a simple drop of blood, even in our own homes, and finding new ways to bring cures to market faster. I am a protector, keeping our oceans safe from invasive species, and helping our crops flourish while minimizing pesticides. I am a helper, assisting customers in stores and the disabled in their homes. I am a navigator, mapping our world 1 millimeter at a time, and making even the largest self-driving vehicles safer for the long haul. I am a creator, learning to paint from the masters and applying their styles to create original works of art. I am a teacher, analyzing 500,000 player moves every game to identify strengths and weaknesses, and a learner, discovering new strategies from complex games. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
If you were to ask me in one word what enterprises need, in one word is intelligence. Intelligence is the only way that they're going to be differentiating themselves each day and making progression so that our lives are better. You require machines that learn, that rationalize, and that they interact. Each time you use Google for search, it magically finds out what your interest is. While you're watching a movie, Netflix knows exactly what your interest in movies is and does recommendation. Your shopping habits on Amazon are captured, and every single page is personalized for you. There are cars which are meandering through the countryside, self-driven. In the night, return back to their garage. They're robots that are learning through trials and errors and are able to equip themselves with motor skills. This is the new computing model. Ladies and gentlemen, I do know each one of us in this room represents the computer industry. And each one of us knows very clearly that we drive some immense societal changes if we underpin each computer model that has transformed our life. Let's look at just two of them which has preceded this era. The number one in 1995 was a PC era where a low-cost microprocessor equipped with a standard operating system Windows and a portal called Yahoo brought over 1 billion computers to desktops and homes. Our life had changed. For some magical reason, 10 years later, the mobile era brought an internet device in our pockets, and with the coming of Amazon's cloud, we have become equipped with applications where 3 billion people enjoy the freedom of mobile computing. And there's something that happens every 10 years in our industry. 2015 is the dawn of AI era. Now, all of us do know AI has been with us pretty much from the time computer science is being spoken about. But what is so special today that we are saying that this is an AI era and it will truly stay? There are following reasons for that. The first and foremost is that there is a change in a computing model. It's a change in computing model where software writes the software, where the algorithm writes the algorithm, where the machine learns through data. The more data that you pour into it, machine learns and signifies what really is. It started off in 2011 with the Google Brain project, where they poured 1 million hours of video onto the computer and asked what are the objects in it. It could differentiate between a person and a cat. In fact, it went on to tell you which were the species of cat, and it could be labeled there. While that was really happening, the real transformation took place in 2012. There was a neural network that was created by Alex Kraszkowski from University of Montreal to compete in the ImageNet program. The ImageNet program used to be the invitation to all computer vision specialists to come and recognize number of images their software could recognize. Year upon year, with years of experience, people would reach 65, 66, 67% of accuracy. That particular year, by training a neural network with million images, the result was 76%. That was 10 basis points more than the best ever result against a human-coded software. Taking a clue from there, people like Microsoft, Baidu worked on, and in 3 years' time, they published a result that not only beat the human-coded software at 66%, but reached human scores of 96%, which meant that we had surpassed human capability. They went on to work on speech. They could now deliver in near real time translation between Mandarin to English in my tone, in my accent, in my style, with error rates less than 3%. So if you go to Skype today, and we spoke about the Skype example 20 years back, the same priest 60 kilometers away from Vizag can not only connect with his granddaughter, but can also speak with the granddaughter's friend in English while he speaks in Telugu. This can be achieved by writing a single algorithm. So the problems of image, the problems of speech, the problem of perception, the problem of context, what humans are good at doing can be equipped with technology. And there is this new way of doing it, which is called deep learning. In deep learning, you train a neural network. What's a neural network? In very simple terms, it's an inspiration from human brains where neurons are connected, multiple layers are created, and each layer gives an input to the other one so that that output becomes the input for the next one. For example, as you know in computers, you work on bits and bytes. So if I have to recognize my face, I have to do it from pixel. The layer 1 will look at pixel, layer 2 will look at the edges, layer 3 will go and construct my nose, layer 4 will probably do my eyes, layer 5 will do my eyebrows, Layer 6 probably will do very little hair on my head, and it will eventually say, this is Vishal. Not only will it tell me Vishal, even if Vishal was on a side track and the camera only got 50% of the picture, it will still say, this is Vishal. And if there was no lighting here and it was in darkness, it will tell me it's Vishal. And in this part, you do not do handcrafted codes. You don't write instruction by instruction by instruction. You actually pour data, data, data on it. The next most important part in this, though, is how do you compute it? Now, all of you in this room do know microprocessors were created so that you could do programming in a sequential way. And there were techniques that were fine. How do we extract parallelism from there? But that had limitations. There was another processor that was created that was meant to take your imaginations towards reality. This processor was created for gaming, where we could conjure artificial worlds. That would be in games, that would be in movies. To doing that, this processor in its nature was parallel. So you needed a processor that was parallel to take this humongous data, apply linear algebra onto it, so it became the third silicon to support the new age of computing, what we call as the AI era or the deep learning era. And that's where GPU, in combination with data, in combination with neural networks, is the new way of solving problems. I did give you some personal examples, how it's making a difference to your life today, knowingly or unknowingly. You know that your Siris and OKs now can understand your context much better. They understand your dialects, they understand your accents. When you say, in the morning when I traveled from Bangalore, the temperature there was 20 degrees. And I said, hey, I'm going to be delivering a session, what should I wear? And in that context, it did tell me that the temperature is good, you like to wear your suits, maybe a light suit would be good because you're going to be in Delhi, where it's going to be 46 degrees of temperature, but the room is going to be cool, so you can actually wear your jacket. It does right now on your systems. And if you're hearing what Google is saying, what Microsoft is saying, what Facebook is saying, what Baidu is saying, what Tencent is saying, that look, we are making a difference because we are adopting AI first. What about the enterprises? What the enterprises are saying, that humongous amount of data that we have got because we created a single infrastructure, an infrastructure that has given us information, where we have a data, how do we make intelligence out of this? I need to be predictive. I want to know that if I am an aircraft engine manufacturer, I have sensors on that, and I put 2 engines per aircraft, and I assimilate 1 terabyte of data every time the aircraft takes off, I should be able to tell the aircraft carriers much before the failure of the engine takes place. How am I going to seep through this data and find out? That's through deep learning. If I want to basically do healthcare and I can understand my genome, can I give you a medication that can prevent you from cancer? And if the doctor is not able to identify because of lack of experience or for that matter of fact fatigue, I should be able to help him and say, I can see a malicious cell, would you like to solve it? If I get ransomware, I should be able to preempt you before that I'm seeing an anomaly in the system, please be careful. That's the power of deep learning. Now, on the count of the first bell, I did count that they give you 2.5 minutes after that, and they'll ring the second bell, and if I don't take a clue, they'll send me a letter. So without wanting to get for the letter, let me again express how deep learning is profoundly making a difference to all of us by doing one more thing, run another video for you.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
Note, I would like to say that the most touching part is that if a blind person can read a book to your own child, there can be no greater excitement in life. And if deep learning at its scale and its power continues to do what it is doing, then the study of KPMG says that this is the fourth revolution of industrial age and at least 200 times the scale of the previous scale. So on that note, I'll leave your imagination, think deep learning, apply deep learning, get your neural networks ready, and make sure your data gets inside. Thank you very much.